Today we will discuss virtual memory. We are done with paging, right? We are done with paging
Yes,
in
sir.
previous class. Okay, so today we will discuss another concept in memory management, which is called virtual memory. Okay, so anyone have any idea about virtual memory? Virtual means imaginary, right? That does not exist physically. Virtual means something that is virtual, which does not exist physically. So uh, I think those students who play game a lot, they can explain what is virtual memory, right? Let's see who can explain what is virtual memory. I just want to know what is like how much you are aware about virtual memory. Then we will discuss. Have any idea? Anyone have any idea about what is virtual memory? Have you heard this word before in computer science? Anyone? Are you there? Simply say yes or no so that I can move. Come on, yes or no? Okay, no one is responding. I think my voice is not audible. Am I audible? Mm-hmm. Am I audible? Oh my god, this is virtual platform. Mm-hmm. Am I audible, beta?
Yes, sir. Audible.
Okay, thank you. Thank you. So, anyone have any idea about what is virtual memory? What is virtual memory? No one? Virtual memory. Okay, so let me ask this question in other way around. Do you know what is hard disk? Simply say yes or no. Do you know hard disk?
Yes, sir. Yes,
Okay.
sir.
Do you know RAM?
Yes, sir.
Do you know cache?
Yes, sir.
So all these three are virtual, or you can see that uh, uh, they can exist in physical form also. Hard
The
disk,
hardest is
RAM, and cache. These are hardware, or something you can say they are software.
no,
Hard
sir.
disk, RAM, and cache. You can place RAM anytime. You can go to NASA in Hazratganj and you can increase your RAM also, right? They can put a RAM in your socket of your computer
Yes.
system and you can increase your RAM. And you have your portable hard disk also, right? Like you can
Yes.
buy
तो
1 TB
एसएसजी
hard
भी तो
disk
होता है.
also, right? And they are hardware. And you know what is cache memory? And that is like they have implemented on your CPU and it is very small in size for the faster memory access, because as you know the travel time from the hard
from the
disk to
hard
the
disk to the
excuse me, the travel time from the data of hard disk to the main memory, it will take too much time, right? Krishna is saying SSD, 2-bit SSD, like something you can say that pen drive, and something you can say that they are portable memory. Okay. Okay. So what I was telling, that your hard disk, your RAM, what is the full form of RAM? What is the full form of RAM? What is the full form of RAM?
Random access memory.
Random access memory. And what is the full form of SSD? Krishna that was referring to SSD. What is the full form of SSD?
Solid state drive.
Exactly. Okay. So now you are aware that all these three are hardware. Your hard disk, your RAM, and the cache, that you can see that these hardware exist in your computer system. Now we are talking about virtual memory. As the name suggests, you virtual memory means memory that's something related to your like data which is stored into the computer system. And I remember one homework. I have given you one homework, right, related to memory. Do you remember? One homework I have given related to something your hard disk. Do you remember what homework I have given related to your hard disk? How data is stored in the hard disk, right? I hope you all are working on it. Okay. Are you working on it? Are you searching how data is stored? Yes. So keep searching until unless you are satisfied with your search, right? Okay. So all these three are hardware. Now we will see what is virtual memory. Means something which is not physically present. Means you cannot have an hardware for that virtual memory. Means we are gonna make an illusion and fool the computer system that you are having a RAM which is like suppose you are having RAM of 4 GB, and with the help of virtual memory you can fool the computer system that you are having RAM of more than 4 GB. And how you are going to do this we will study today. Means how we can expand the main memory which is not exist actually. We are going to do this with the help of some mechanism, and we will see what is virtual memory. What we will do, we will make a hardware portion reserved for the virtual memory, and it can give an illusion that the part of that your hardware that is your hard disk is added up to the memory space of your RAM. So your capacity of your RAM has been increased, and it will give an illusion to the any program. Just like I told you that those students who are playing game a lot, they can understand what is virtual memory, because whenever you are having a high end game playing in your computer system, it demands a lot of RAM. And suppose you are having only 2 GB RAM or 4 GB RAM in your computer system, you are not able to play that high end game in your computer system. Then we will do something. That means we will set up a virtual memory, and it can give an illusion to your computer system that you are having like 6 GB RAM. And that extra 2 GB that your computer system is having an illusion that you are having a 6 GB RAM now, which is a part of your hard disk, but it give an illusion that you have increased your RAM. So let's see how it gonna be done. As you name the suggest, it is virtual in nature. That means there is no specific hardware you are gonna add for this. You can program it. Okay, so let's see. I am sharing computer system screen. Let me know if you are able to see the screen. Screen is shared. Uh, my screen is visible. My computer screen is
Yes,
visible.
sir. Yes, sir.
Yes, okay. So let's move on. Let's move on. Today's topic is virtual memory. So, what is virtual memory? Virtual memory involves the separation of logical memory as perceived by the user from a physical memory. Means the crux of this statement is you are gonna make the computer system illusion that you are having more uh, main memory. And this separation allows an extremely large virtual memory to be provided for the programmers when only a smaller physical memory is available. As you know that your physical memory is less, but with the help of virtual memory you can give an illusion that you are having extremely large memory in place for the execution of the programs. So, what is virtual memory? It allows execution of programs that may not be completely in memory. So, with the help of your virtual memory, it allows execution of those programs or processes which are not completely in the memory. What is the meaning of complete program in the main memory? Whenever you are executing a program, it the loader which is in place will pick those programs, complete program from the hard disk to your main memory. But sometimes you know that suppose you are playing a game of like suppose you have played Counter Strike, right? In Counter Strike we are having a number of maps. Have you ever played Counter Strike? Anyone? Have you ever played Counter Strike? Are you there? Am I visible? No, please be with me. I am not able to understand that you are listening or not. Have you ever played Counter Strike game?
No, sir.
No. Okay, have
No,
you
sir.
played
No gamer
PUBG?
in the house.
Okay, have you played PUBG? Or like,
Yes, sir.
have you played Dota?
No,
Defense of
sir.
the Ancient?
No.
Okay, have
No,
you
sir.
played NFS, Need for Speed?
Yes,
Yes.
sir. Yes,
Okay,
sir.
that's cool. So now, if you're talking about NFS, Need for Speed, which version? Hot Pursuit or Underground? Which you have played?
Sir,
And which is the
underground.
latest one we are having? Yes, beta?
The latest one don't know. Underground खेला है, latest नहीं पता.
Okay, so you're not aware about the gaming industry. Don't you want to go there?
No, sir.
Okay.
No, sir.
What? Tell me the production house name of NFS. Tell me the production house.
Game Loft.
Game Loft.
Game Loft.
Your voice
नहीं
is
ये था
cracking.
EA Sports.
Yes,
Sir,
EA Sports.
I
And what is the full form of EA?
electron.
Your voice is cracking better. You can type in the chat box. You can type in the chat box. What is the full form of EA?
Electronic Arts.
Exactly. Good. So now what I am going to explain you that you have played NFS, Need for Speed. In that particular game, you have seen a number of levels, right? A number of maps are there that you want to ride in your mountains or you want to ride in your deserts. Some different type of maps are there, right? Yes or no? Yes?
Yes, sir.
Yes, exactly. And there is also they are making games such like they are putting them in levels. Like if you are able to win first race, then only your second race will be unlocked. Or they are in some scenario they are making some 4 to 5 race open, and if you are winning those 5 to 4 races, then other maps will be unlocked. Is it so? Okay, so cool. So now, if have you once you are like installing that Need for Speed, it is taking a lot of space in your hard disk, right? Because it is installing all the maps which are gonna play in that Need for Speed, and that is going to be in your hard disk, right? And suppose if you want to play that particular, this is a single program, right? Need for Speed is a single program. Now you want to run the game of this Need for Speed, you need to put that a large amount of files and data which is stored in your hard disk while installation of the Need for Speed game in your hard disk. You have to gather all that data and put it into your main memory. Only then your program, your Need for Speed game will run, right? And you have seen there is written that what is the minimum requirement of RAM for running this Need for Speed. In every game, they write what is the hardware requirement for particular running that program, right? Got it? Got it? So what happened now, if you are having a 1 GB RAM, suppose, and your requirement of your Need for Speed is 2 GB, then if you are trying to uh, run that Need for Speed on your computer system which is having only 1 GB RAM, then what happens? Suppose your Need for Speed is required 2 GB data in your hard disk and it has to put into your main memory. Now you are not able to pick all those data in your main memory and your program will not run. It will crash, right? Or it will lag a lot. So what virtual memory is gonna do? It can give an illusion to you that game Need for Speed that you are having 2 GB of RAM. What it will give? It will give an impression by making a virtual memory and adding up into the RAM. And then that manner it can run that Need for Speed program. And how it can give this illusion? As I told you that only 2 to 3 maps are unlocked initially, and once you are clear, then only other maps will be visible to you. So what it this virtual memory gonna do, it will load complete program and put those unused maps into the virtual memory in the hard disk itself, and only those maps which are uh, unlocked right now that can be put into the main memory, and that having a less space which can accommodate into the 1 GB itself. So in 1 GB you can play that game, 1 GB RAM, you can play that game very easily, and those logged maps are put there into the virtual memory that is in the hard disk itself. And once you are clear that level 1 or one map, then what will happen, if you are clear one map, you are not gonna play that map right now, you are requesting for another map, then what will happen, it a this virtual memory is gonna put that unlock map which is right now unlocked from your hard disk to the RAM, and uh, pull that map which you have already cleared into the virtual memory. In this manner, this virtual memory gonna give you an illusion to the computer system that you are having more RAM. Now you clear what is the use of virtual memory, everyone? And I have give you a glimpse how this virtual memory is gonna help you by making unused modules and the sections of your program into the virtual memory, and only those modules and sections which you are using right now is gonna put into the main memory. And how it can be done, we will discuss in today's lecture. Concept is clear that you don't need to load a complete program into the memory, right? Right? Got it? Are you
Yes, sir.
there?
Yes, sir.
Okay, so let's see how we can do so. So what is the first line? Virtual memory allows execution of program that may not be completely in the memory. Means your program is completely not in the memory, but it is still executing. So logical address space can therefore be much larger than physical address space. Allow address spaces to be shared by several processes. What we are talking about? Address space, that is, we are talking about your someone. Shweta, you can mute yourself. There is some hindrance in my voice. Shweta, where are you? Uh, let me mute. Okay. Okay, so allow address space to be shared by several processes. Each user take less physical memory, so more programs can be run at the same time. That is, each user take less physical memory in the sense that you are using a less physical memory because you have putting all those data into your virtual memory. So more programs can be run at the same time. Physical memory, we are talking about your RAM. CPU utilization and throughput increased with the help of virtual memory. Your CPU utilization and throughput increased. How your CPU utilization and throughput increased? Because you can accommodate a number of processes at a time in your CPU because your RAM is free to accommodate more processes, and your throughput will be increased. Throughput is the number of processes executing at unit time. So once you are increasing the degree of multi-programming, then throughput will also be increased. But the thing is, your response time and turnaround time do not increase. Okay, so what is the what like advantage of using virtual memory? CPU utilization and throughput will be increased, and rest of the things like response time, turnaround time will not increase. So less input output needed to load and swap user programs, so each user program run faster. Now you can see this diagram. Here you can see this is your hard disk, your backing store, and here you can see a stack of physical memory. Means you can get data from this hard disk, and here is your virtual memory. In virtual memory, we are having pages, right? Page 0, 1, 2 up to page V, and here is a memory map. With the help of this memory map, we can put our pages of virtual memory into the physical memory. This diagram showing virtual memory that is larger than the physical memory. As you can see, physical memory is of this size only, but this virtual memory gives you an illusion that you are having more physical memory. You can, what your computer system see this virtual memory as your physical memory, that is your RAM. So let's see how this actually implemented. Virtual memory can be implemented. We are having two techniques. First one is demand paging, and second one is demand segmentation. So today we will discuss demand paging. What is demand paging? As the name suggests, demand. Whenever there is a demand in the market of that particular page, only then we will supply that page. What I am telling you, whenever your program is requesting a particular page, or you can think of in a particular module of your game, then only we can give you that particular module of the game once you are demanding that page. So in demanding paging technique, in demand paging technique, pages are loaded only when they are demanded during program execution. Pages that are never accessed are thus never loaded into physical memory. So as I told you that you are having a number of maps in your need for speed, but if you are not able to clear your first and second race and you are not getting enough coins to unlock more maps, then those maps will never be loaded into your physical memory because you are not using them anyway. So by doing this, what is the advantages we can get? Less input output needed, less memory needed, faster response, and more users can accommodate at a time. So this is the beauty of demand paging, that only those things that are requesting we can go for that thing only. And now here you can see demand paging. We are gonna do that transfer of page memory to contiguous disk space. How this gonna be done? Here you can see this main memory, and here these pages are allocated, placed into your hard disk. Now you can swap out this program A. Once suppose you can think of this as map 1. You are done with map 1, so this map 1 will be swapped out into the hard disk, and this map 2, which is located in page 17, 18, and 19, that will be swapped into the main memory. Now as you like your need for speed is thinking that it is using a more RAM, but that program A which is useless now, program A that is your map A is useless now. You are not playing this map A, so we have swap out and swap in your next map, which is you will play now. So this is the transfer of paged memory to contiguous disk space. You can draw these diagrams in whole page in your external examination. I am telling you every time, please don't put a very small diagram in the corner of your answer script. So let's discuss the basic concepts of demand paging. We need a pager. What is a pager? It will decide which page will be swapped out and which page will be swapped in. When a process is to be swapped in, the pager guesses which pages will be used before the process is swapped out again. Now, how this pager is guessing that which page will be required, we will discuss later on in the uh, page replacement algorithm, which we will discuss in our next lecture. So we will see how this pager is guessing which page will be used before the process is swapped out again. Instead of swapping in a whole processes, the pager brings only those pages into memory. Thus, it avoids reading into memory pages that will not be used anyway, decreasing the swap time and the amount of physical memory needed. Means the working of the pager is to decide which page is gonna swap out and which page will be swapped in. In this manner, the pager will avoid reading those memory pages which is user is not going to use, and in this manner it will increase your efficiency. So let's have a diagram how once you are place swap out program A, and then we can make some valid and invalid bit associated with those pages. So with each page table entry, a valid and invalid bit is associated. V stand for in memory means it is valid bit, and I that is invalid bit, that means that page is not in memory, means there is a page fault. What is the meaning of page fault? That page you are looking for is not in the main memory. Let me check if you are listening or not. Okay, my screen is visible. Okay, so here you can see we are having this backing store, and you can see we are having some processes A, B, C, D, E, F, G, H are placed in the backing store. We are having this physical memory, a page table, and the logical memory. In logical memory, you can see here are the page numbers 0, 1, 2, 3, 4, 5, 6, 7, and you can think of the name like these processes A, B, C, D, E, F, G, H, and then there is a page table. In this page table, here 0, 1 to 7 are page number, and here are the frame number. Means there is a mapping of pages into frame, and if that page is mapped to the frame 4 exist in the physical memory, then we put here another a column which name as valid and invalid bit. And if it is in memory, V is there, and you can see in frame 4 here in physical memory, this is frame 4. I guess you can see the cursor of the mouse, frame 4 is here and A is placed in the frame 4. This belongs to your page 0, and page 2 is in frame 6. You can see in frame 6 C is placed in frame, page 5 is in frame 9, and F is there for the page 5. So these A, C, and F are in frame number 4, 6, and 9. 4, 6, and 9. So if they are exist, then we can say a valid bit is placed that these are in memory, and rest of the things we can put I. Means invalid bit means these pages are not there in the physical memory. So we have a page fault for page number 1, page number 3, page number 4, page number 6, and page number 7. We are getting page fault. Page fault means miss. Means you are looking for a page which is not there in the physical memory right now. Means you are looking for a map which is not there in the main memory right now. You have to call the hard disk to swap in those maps. That is your page 1, that is B, D, E, and G and H. You have to pull from the hard disk. So this is the working of uh, demand paging. TPS table when some pages are not in memory, and those pages which are not there in main memory are treated as page fault. So let's see what is the performance of demand paging, how it can help you.
एक्सक्यूज मी सर सर
Yes.
स्क्रीन नहीं दिख रही है
Okay, let me check.
सर वर्चुअल मेमोरी दिख रही है सर काफी देर से इसी पे सर रुकी हुई है
Okay, I think your internet connection is slow.
सर मे भी
I am again refreshing my screen. Am I audible? Am I audible? Yes or no?
यस सर
Okay. And is there any issue for other students also? Are they able to see the screen? I am sharing the screen. Now I am sharing once again. Okay. Now screen is visible. The screen is visible.
यस सर नाउ
Yes,
इट
sir.
इज
Okay.
यस सर
And which is the last page you have seen? Have you seen this page? Demand paging basic concept, valid and invalid bit. I have explained. Everyone is understand?
Yes, sir.
Yes, sir.
Okay, so now let's move on for the performance of demand paging. Last topic of today's lecture. Let's see how our performance of system is increased with the help of demand paging. So let memory access time is MA. MA is denoted as memory access time. P be the probability of page fault. What is page fault? P is the probability of page fault. What is page fault? I have explained right now. What is page fault? Come on, tell me. What is page fault?
When the page doesn't exist in the physical memory.
Exactly. If you are looking for a page which does not exist in your main memory, then we can say that we are getting a page fault, right? Right? Okay. So that probability of having a page fault belongs to 0 to 1. And then see what is the formula for this. Effective access time is 1 minus p into memory access time plus p into page fault time. If p is the probability of page fault, then 1 minus p is what? You are getting the page into the main memory, right? If p is the probability of page fault, then 1 minus p is what? Tell me. If p is the probability of page fault, then 1 minus p is what?
valid.
Come on.
Probability of not finding page fault.
Probability of getting that page into the main memory, right? So if you are
Yes, sir.
getting the page into your main memory, that you have to multiply it with the memory access time. That how much time it will take to search into your main memory where that particular page is residing. So 1 minus p into memory access time plus if you there is an invalid bit means that page is not exist into the main memory, that means we are getting a page fault. Then we have to multiply p with the page fault time, means what is the time to swap in that page from your hard disk to your main memory. So that time taken is combined into this page fault time. So what is the effective access time? P into page fault time plus 1 minus p into memory access time. So three major components of the page fault service times are service, the page fault interrupt, means if a page fault comes, then you have to service that, and then you have to read that page from the hard disk and then restart the process. So these are the three major components. Service time means whenever a page fault occurs, means whenever you are not getting that page in your main memory, then you have to service the page fault interrupt, means you have to go to the hard disk and swap in that page into your main memory, and then you have to read that page and then restart the process from where it is requesting that page which is not there into the main memory. So let's have a numerical on this. With an average page fault service time of 8 milliseconds and a memory access time of 200 nanoseconds, the effective access time in nanosecond is, can you calculate this? Effective access time, and take the p value as 0.5. P is your page fault time. Take the p value as 0.5. So what is the formula? Effective access time is equal to 1 minus p into memory access time plus p into page fault time. So page fault time is given as 8 milliseconds and memory access time is given as 200 nanoseconds, right? And p value is given as 0.5. Now calculate the effective access time. Come on. You know the formula? Sorry. Come on, do it fast and then we are done with today's class. Come on. As soon as you will give the answer, we are done with this. Effective access time. What is the formula? 1 minus p multiplied by memory access time plus p into what? Page fault time. Page fault service time. Page fault. So what is effective access time? Let p value as 0.5. I am writing here. Let p is equal to 0.5. Okay. Means there is a 50% chance of getting that page into your main memory and 50% chance of page fault. So now calculate 1 minus 0.5 into memory access time. What is the memory access time? It is 8 millisecond, right? 8 millisecond. And then we are having p value as 0.5 multiplied by page fault time. What is page fault time? Oh, sorry, page fault time is 8 milli. And this is 200 nanoseconds. Memory access time is 200 nanoseconds. And here 0.5 into 8 milliseconds. Everyone, have you got this equation? Are you there? Are you there?
Yes, sir.
So everyone has got the same equation.
Yes, sir.
So now for doing this calculation, what you have to do before doing the multiplication and addition, what you have to do?
Conversion, sir.
And which conversion is suitable right now? Are you gonna
Second.
convert millisecond into nanosecond or nanosecond into millisecond?
So both into seconds.
Which one?
So both of them into seconds.
Then you will have a lot of
So
values in
milli to nano.
decimal, right? Then you will
So
have. So it will be better that you convert everything into nanosecond, right?
okay,
So
sir.
that you don't have to deal with the point values, as you know, in normally we truncate decimal values after three places, right?
Yes, sir.
So now convert millisecond into nanosecond and you will get the answer.
Okay, sir.
Tell me the answer. Come on. And we are done with today's class. In next class, we will discuss page replacement. What is page replacement? And if we time allows, we will discuss page replacement algorithm also. Come on. Millisecond into nanosecond. Come on, come on. Anyone? Answer? Where is our answers? Yes, tell me. What is the answer for this? What is the effective access time for p-value as 0.5? You can change p-value as 0.7, 0.8 in next another question if you want to do the practice. Come on. Come on, come on. Do it fast. We are this is 9:41 a.m. Come on. Tick tick 1, tick tick 2, tick tick 3. I guess no one is having calculator, but everyone is having their smartphone, right? And those who are taking class on the smartphone, I guess they are having very difficulty in switching the screen. Is it so? Oh, such a constraint in this online class, as I am not able to see what my students are doing right now and how they are calculating the answer. Come on. Come on, at least three answers I required from your side. Simple arithmetic operations. 104 into 10 to the power 6. Okay. Let's see what about other students. Come on. Prince, this is saying 4000100. And see, Prince, and others, you are missing essential ingredient of your answer. What you are missing? Can you tell me? What is the essential ingredient of your answer that you are missing?
Nanosecond.
Exactly. Without unit time, how you can justify what is this 4000100? I need one more answer and then we are done. One more answer, please, from another student. One more answer, please. One more answer. Come on. Come on, come on. Come on. Come on. Now, Ananya is saying the unit is millisecond, but Prince is saying the unit is nanosecond. Prince, you are saying that your answer is in nanosecond, and Ananya is saying her answer is in millisecond, and your digit is same, 4000 and 100. Who is correct? Now Shreyas is saying this is in nanosecond. So Ananya, can you check? Ananya Pata, can you check your answer? Okay, now she has corrected. It is in nanosecond. Okay, cool. So I guess everyone is able to understand. Now, if I am giving you one homework, you have to calculate the same thing for p is equal to zero point 0.7. Okay, and this is question one. Question for the homework. Question one, p value is 0.7 and everything else is the same. And question 2 is, question 2, let p value as 0.8. Okay, so you have to calculate the answer for this. This is just for your practice. Everything will be the same and you have to just change the p value. Okay, and rest will be the things will be the same. I will upload today's class lecture note in the Google Classroom. And for generalized p, let's see how you can generalize this. Effective access time is 1 minus p into 200 nanosecond and plus p into 8 milliseconds. Now you can convert these milliseconds into nanoseconds. 1 minus p into 200 plus p into like this 8 triple 0 and triple 0, and p value we have not placed. We are generalizing this because with the varying page fault we can have a single equation and we can get the answer. Now 200 plus 7,999,800 into p. Okay, so here you can see that you can change p value as 0.7 or 0.8 or 0.9 and you will get the answer. So this is generalized effective access time we have find out with the help of the data given. Like page fault service time is 8 milliseconds and effective access time for 200 nanoseconds. So everyone is clear how to solve this type of question. And very rarely you will get this question in your examination. In masters, this type of questions comes in the examination, but in bachelor's degree I have not seen till now that this question has been asked in the examination. But I think if you are lucky, then you will get this easy numerical in your end semester examination. So can you solve this question if this question comes in your examination? Yes or no? Can you solve this type of question if this question comes in your examination? Tell me yes or no.
Yes, sir.
Okay, thank you. This is called confidence, right? So have confidence in you that you can do anything. The thing is, you have to study and you can do anything that you want. Okay, so we are done with today's class. This is homework for you. You have to read about lazy swapper, pure demand paging, and the locality of reference. Please write it down. Homework, you have to just have a good read on these three topics. What is lazy swapper? What is pure demand paging? And what is the locality of reference? Okay, take the screenshot or you can write it down. Lazy swapper, pure demand paging, and locality of reference.